So this will be a first attempt to give some hints to people who are still working on homework number 2. In this example, I've got a data set that we've downloaded from the market intelligence platform, the Standard & Poor's site, to Excel. So I'm going to assume that you've been able to get a data set either from the discussion board or that you've been able to download it directly from SNL. And one thing I want you to notice is that in this file, there's only one row of headers that if you've downloaded directly out of the SNL platform, there's several rows that have some variable numbers that they use to refer to the fields in the data set. And so when you've got that kind of data, you're going to want to clean it up to look like this set here. So in here, this file, we have company name, we have a key for the rate filing event, the state, a filing type, and as you go to the right, you see there's some dates. So we're going to focus on those date variables for this this little tutorial. And yeah, there's the date submitted over here that I care about. The date that it was actually published. The information is usually the latest date that's in the record. The disposition date is the date that the decision was made by the insurance department. We have the number of pages in the file, and you can see in some cases they're very short, as low as 12 pages, but then some are as much as 11,000 pages here for 21st century. So in this example, maybe the number of pages is some reason why it takes longer. We could check that. Then there's some information off to the right here with the amount that the insurance company is requesting for their change in premium. The indicated is what the actuaries have indicated is the necessary amount or is a reasonable amount given the risk that the insurer faces. This next in column O shows what the insurance company actually asks for. So you see mostly they ask for the same amount that the actuaries have suggested. Sometimes they come in less. Usually they do not ask for more. So as you look down here, all of the ones here on this page, other than those where there's no actuarial report and a very small change in this case, most of these are the companies ask for less than what the actuaries have suggested, and that may be because the competitive pressures, they don't want to actually ask for as much as what's indicated by the actuaries. And we have some number of policyholders affected, some written premium change, some other details here, including the rate filing method, whether it was under a file and use, prior approval. Because that's all that's showing up right here. The rate change type, and then some more information. And in this file, we even had some information about the distribution channel, independent agency type of distribution, or in this case, captive or direct response, independent agents. These are larger insurance groups in some of these cases. We've got the AM Best rating, expense ratio, which is largely missing for these observations, some other data here. And this was all extra information that might be useful to look at some other hypotheses beyond what was in the homework. So what I'm going to do is I'm going to take this data and I'm going to cut down to just some pieces that I want you to focus on so we can see it all on the same screen. So I'm going to take this information out. In fact, I guess I'll leave in the amount that the insurer is asking for, but I'm going to get rid of these fields. And then when I go back over here to the left, there's some stuff that I don't need. So I suggest you do some of this cleanup. It's just less that you have to then transport up to the Stata on the virtual lab. We don't really need the name or the filing key. We do want to know the state, so we're going to keep those. I'm going to delete those first two columns. So we have state, maybe the type. I believe this is all auto insurance, so we can test that real quick. Let's see what we got here. We've got personal auto, yeah, just personal auto. So this variable doesn't do us much good. And so we just get rid of that because it's the same for every observation. Maybe we're interested in knowing whether we're going to look at RVs or motorcycles or something else under the auto, so we can keep that. And then I want the date submitted. I'm not really that interested in these other dates here. Mostly I want to know when it was submitted, when it was disposed. Again, the filing company, we can get rid of that. And maybe we leave in then what the actuaries suggested and what the company wants, and we'll just get rid of the rest of this stuff for now. So I've got it down to 9 variables here, and let's turn off that filter. Now what I want to do is make some things easier in Stata as well. I'm going to change a couple of these headings. So filing state, filing type, those will be okay. The subtype of insurance, I'm just going to give these shorter names because I like working with shorter names. We have the date submitted, filing status, number of pages. Here I'm just going to call this indicated, and I'm going to call this requested. Right, so that should be it. And then let's just check and see what we have here. If I go control down to the bottom, I've got 14,675 minus the headings means 14,674 observations. All right, now I'm going to go and open up my browser. And from the browser, I'm going to go to the FSU Virtual Lab. All right, and get ready with my Stata. So Stata is all ready to go. Then I'm going to come over here and I'm going to copy my entire spreadsheet. So I highlight it all, Control C to copy. Close that, and let's go here to the clipboard. Paste it. And then I'm going to copy this, Control A, copy, and I'm going to go over here to the data editor, paste here. And here it's asking me if the first row contains variable names, and I say yes, they do. All right, so here now I have filing state, filing type, there's my subtype of insurance, right? There's my, should be 9 variables, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? All right, so the data's all there. I can close the data editor, and then just to confirm how many observations we got, if I type in SU, what you'll notice is that I have, 14,674 observations, but only one of all my variables is numeric, so that it can actually be summed. All the rest of these variables are in text in some way, and that means that I can't do a summation. Sorry, I'm going to adjust my screen to make it a little bit bigger. Okay, so what we want to do is see if there's something about the how long it takes across different states. So the first thing I'm going to do is just look to confirm what kind of states we have here. So I'm going to tabulate filing state, and you'll see we have Florida, Georgia, Louisiana, Tennessee, and Virginia. We mostly have, well, Florida we have the most of, then Georgia. Right, so you see the distribution there. And one problem that many of you are facing, and we'll see how this goes here, is what to do with those dates. So we look over here, you see disposition date and the date submitted. If you click on one of those, you'll see that there's strings. So there's a string of 10 for date submitted, that disposition date, string of 10. So one thing you can do, you'll see that you can't just take the difference between those to find out how long it takes to dispose of a filing. What we have to do is create some other variables. So I'm going to create D1, which is going to be my date submitted, and I'm going to use a formula or a function called date to take that date submitted variable, and I'm telling Stata that that variable is in the format of month, day, year. All right, so if that worked, I should have a numeric variable now, D1. So let's see what D1 looks like. And I do, it runs from, let's see if we can make this a little wider. Well, it runs from 19,953 to 21,591. That is the number of days, that value, the number of days since January 1st of 1960, I believe. So that gives us an integer number from which we can calculate differences in time. I have to do the same thing for my second date, so that's the disposition date. So I do the same thing there. And now let's see what D1 and D2 both look like. So we see very similar dates, right? And we're in the same date range for all of these. And now I can generate a variable that I'm going to call, let's call it disposition time. And that's going to equal D2 minus D1. And now let me see what that looks like. I'm going to do SU disposition time comma DE, which gives me more descriptive statistics because it gives me the percentiles. It gives me the mean like I would have gotten up here when I did D1 and D, just a plain SU command. I get the minimum and the max, which are here, 729, the smallest 0 days. And this is the number of days between the time it was submitted and the time that a decision was made on the filing. Okay, so for just under 5%, at least 1%, the filings are approved at the time that they're submitted. So those might be use and file rate regimes where, and maybe even some file and use regimes where the date is entered immediately. I mean, it's approved immediately. Then we have 50% of them, of these filings, take 25 days between the submission and the disposition. And then we have some really big ones that may be outliers. It may be some that never got resolved in some way. So we might be a little bit concerned about that. And even 264 says it's basically a year from the time that something is submitted before there's another approval. So I might even be a little bit suspicious about why it's taking a whole year. We can do some things now with this information. For instance, we can look to see if there's a correlation between the disposition time and the number of pages, right? So we have that as a variable. So we could say which is correlate, we can write it all out, number of pages, disposition time. And we find that there is a correlation of 0.19 in a positive direction. So longer time to dispose of a case if it has a longer number of pages, which does suggest that there's some scrutiny going on by the insurance department. Those longer cases might just take longer to review. We haven't cleaned up the data yet. If I'm a little bit concerned about some of those really long disposition times, then what I could do is create a variable. I'm going to call it trim time, and that's going to be equal to disposition time less than, let's say 660, no, let's say 265. All right, so if the disposition time is less than that yearly or 265 value, and I used a command that doesn't even exist in Stata because I said the word create. Okay, so generate trim time And now if I do that correlation again, correlate number of pages and disposition time, but I'm going to do if disposition time, let's say if trim time equals 1. So when I generated trim time, I actually created a 0, 1 variable. 1 if disposition time is less than 265, and 0 if greater. So I'm going to end up with losing 5% of my sample when I do this, but we'll see what this does to our correlation. It actually makes it better. So even though we had some outliers on the disposition time, our relationship between disposition time and the number of pages is a little bit stronger, slightly higher correlation now when I've left out those outliers. Okay, so this is one way to treat those outliers. Another way, and I won't enter this, but you could also drop if disposition time is less than 265. If we do that, though, we lose those observations for good. So we don't really want to do that, just in case we want some other information from those observations. And that reminds me, right now is probably a good time to save this information. So I'm going to save rate data 1, just in case we make a mistake later on. All right, so we've got our date submitted variable. We might want to see, for instance, if two different states, remember we had the filing states, Florida, Georgia, Louisiana, Tennessee, and Virginia. So one thing we could do is let's just look at the mean of the filing of the disposition time for each of these states. So there's a command that says we're going to sort by state, and then by each state we're going to do SU, summarize disposition time. All right, so I ran that. If we go back up here now, you're going to see what it did is it did an SU of disposition time for each state. So Florida, the mean is 44, Georgia 37, Louisiana 41, Tennessee 20, Virginia 56. All right, so those are the means, but I can't say anything other than the fact that the means are bigger than in one state than another, but I could do a statistical test here. So here's a test called a t-test that compares the two distributions. I'm going to t-test disposition time, and I need to pick two states to compare. So I'm going to compare if filing state is equal to Louisiana, or, so that was the lowest. Now let's put in Tennessee as the lowest, or filing state equals, what was the highest here? Virginia. And then I'm going to do by filing state. So just a couple points about this. So the t-test, you give it a variable, and then you typically follow it by a variable that takes two values. So normally we'd have t-test disposition time by filing state, but we have more than two filing states, so we have to limit here with the if Tennessee or Virginia before we can do the test. So another example would be a t-test income by gender, where you have male, female, and you only have two outcomes. So t-test will fail if you tried to say t-test disposition, comma, by filing state without limiting your sample in some way. So I had to do this if here to limit my sample just to two states, so that when it says by filing state, there's only two cases. Okay, can only test two things at a time. So when we do this, we get some summary statistics first. So it tells me that for Tennessee and Virginia, the number of observations I have, the mean was 20 for Tennessee, Virginia was 56. I get standard errors and standard deviations. I have a confidence interval. When I look at this confidence interval, I see that they don't overlap at all. So I'm pretty comfortable in thinking that this is going to be statistically significant. Now I can go down here and look at the statistics at the bottom. These t-tests tell me that if I'm testing a hypothesis that they're different, I would, that they're the same, I would reject that hypothesis in favor of them being statistically different. And if I wanted to test the hypothesis that Tennessee is statistically less than Virginia, I would also support that hypothesis, okay? But the hypothesis that Tennessee is greater than Virginia cannot be accepted here, or I would not be able to support that hypothesis. So it moves in the direction that the statistical tests move in the direction of the data that you have. You can make some sense out of that. Mostly in a test like this, I'm looking to see that that 20 is in fact lower than 56, and that's what this result tells me. It's with such high confidence, this is like 99.99999 confident. So let's look at one that maybe isn't as likely to be significant. If we look at Louisiana and Georgia, right? So, and by the way, when you're back in the command window, if you hit page up, you can get your last command. You can also go over here and click on your last command in your in this command window over here. But I want to change this now. I'm going to look at Louisiana, and Georgia, right? And we're going to see if these are significantly different. So 37 and 41, when I look at these confidence intervals for 95%, I see that they still barely overlap, right? The 39 is the 95% percentile of the Georgia distribution. The Louisiana distribution starts down here at 39. So when I look down here at my statistical tests, they're not all as significant as before. I still have support for the fact that they are significantly different at the 98th percentile. And I have support that Georgia is less than Louisiana significantly at the 98.0595 level based on this, so almost 99 percentile. Okay, so that's a t-test that allows me to say a little bit more than just some kind of visual representation. Some of you did plot some graphs looking at how these things compare over time. Right now, I still have, if I look at a summary, I still have all 14,674 records or filings. So if you try to plot these, you end up with 14,000 points on a graph, which isn't very helpful. Instead, what we might want to do is to look at some kind of average, like we were looking at up here, where we had 37 and 41. Of course, this was across our whole time period. But we could look at some kind of average by the state, and maybe even, let's see what we have for the, well, let's just call, look at how this might compare across the states. I'm going to try to see if I can get the year value out of the date submitted. Let's see. I don't know if that works. Oops. So we're going to tab Y1 there. Okay, so we do have a variable now I created called Y1, which is the year 2014, 15, 16, 17, 18, 19. All right, so this is going to let me do some kind of graph over time. And I want to do the average for the states over time. So in order to do that, I need to collapse my data down to means for each state. So I'm going to do the mean of disposition time. I'm not going to worry about those outliers. They are probably skewing the mean a little bit, but I'm not going to worry about those right now. I could drop or keep those away from out of the collapse command here, but I'm just going to keep them in for now. So I want the mean of disposition time, and I want to do this by filing state and my new year variable. Now when I do this, what I'm telling it is I want for every filing state for every year, so my 6 years for my 5 states, I want the mean of the disposition time. So when I run this command now, you'll see that I've lost all my other data. What I have left is filing state, my year variable, and the disposition time, which is now the mean of the disposition time. If we look at this, we'll see we only have 30 observations now. So 6 times 5 states over 6 years. Here's my my values, and if we want to then do some kind of graph, let's see if we can do this. I don't know if I can do it by Alright, this is where I don't have a whole lot of experience with these. Alright, so let's just do one. There we go. Okay, so this shows me over time. If I had a bigger window, it might have given me the years a little bit better. It shows me the disposition time by year in each of the states. So Florida, Georgia, Louisiana. So here's the patterns in each of those, and you can see visually some of the differences. You know, Tennessee being much lower, and especially getting lower. All right, most of these are coming down over this time period. Georgia had a peak at some point, so maybe over time it's maybe not the thing to be looking at for some states. We might wonder why we have so much an increase followed by a decrease in some of those states, or why there is even a decrease. And so some of you submitted some kind of graphs like this, or you know, did some visual comparisons like this, but it's not until you do something like those t-tests where you can say whether or not the pattern, say in Louisiana, is actually significantly different than any of these others. So that's why I showed you the t-test in this. But this is one way that you can take all those 14,000 data points and summarize them into a series of graphs instead. Okay, so I think that from that you should have a pretty good number of commands that I've tried to introduce you to in this. They're all over here in the window, so you can take a look at. We did a tabulate, which just takes a variable and tells you how many you have of each of those. I should say, if we wanted to do something with some of the other text variables, we might have had to create another variable. So suppose that filing state is, well, that's not a good example. I'm going to go back to our other data set. So I'm going to go back to, what did we call it? Rate data 1. So I'm going to do a clear now, clear out the memory, and I'm going to use my rate data 1 again. So this will just take me back to where I had all that original data. And now suppose I'm looking at something like that subtype. I'm just going to see 1, 2, 3, 4. So there's 5 subtypes. Most of that is private passenger auto. But let's say I wanted to look at the other types as separate types in some type of regression. So I'm going to look at disposition time and whether it takes longer depending on the type of insurance that you have. So again, my hypothesis might be that private passenger auto, the insurance departments are very familiar with those. They do them quickly, but the other types might take longer. Okay, just throwing that out there as an idea. But I'm going to have to create some variables. So I'm going to create RV is equal to subtype, and here here I'm going to use a command that says substring of subtype starting at position 1, and for 1, 2, 3, look over here at 19, 1, 2, 3, 4, 5, 6. The first 7 characters are equal to 19.0003. Alright, so if I say generate a new variable RV, which is going to be if subtype position starting at position 1 to 7 is 19.003, that's going to be an RV type, and if it's not true, then it's going to be a 0. So that command takes text and turns it into a numeric. If I tab RV now, you'll see I have 523 that are 1, true. The other 14,151 are false. Right, so I can do the same thing then for, I'm going to generate motorcycle. And that's going to be if it's 19.002, right? So let's tab, there's our 671. And what else do we have? So we had, I don't really know what other is, but I'm just curious about whether RVs and motorcycles take longer than all the other types. So I can do a regression now, and we're going to look at disposition time as a function of whether it's an RV or a motorcycle. And those will be relative to the omitted group, which is my other category is all the other types. So when I run this regression, it's like running against a variable like male, where the male coefficient is going to say how males compare to females, which you would leave out in the regression. We could also put in here just to see, because we saw that there was correlation, let's put number of pages in. Alright, and I'm just going to run that regression and see what we get. So what I find is, in the top part here, you'll see that we had 14,037 valid observations. Our R-squared is about 4%, so we're only able to explain about 4% of the variation in disposition time by these particular variables. What I do find is that if it's an RV, there's a significant 5-day difference, significant at about the 98th percentile. 5 days longer to get an RV rate filing disposed. Motorcycle is less, but you'll see that that's not significant. So motorcycles do not take any more time than an RV to be approved. The number of pages is positively related, but in a very small way. So an additional page causes an additional 0.004 days, but if you then take that to maybe 1,000 pages, you're talking about 4 extra days to process. Okay, so there's another way that you could analyze this particular data set. Okay, and if you have any questions, let me know. I'll be producing some more examples like this as we start to work on the Medicaid data.